In this part of 2.6, we're going to look at describing the changes of a graph of a function when you're looking at the actual equation. So, example 5, we have y equals -2 times a function, which is saying f of x plus 3 minus 1. So let's describe what happens to the graph. What I like to do is I like to think about PEMDAS and work myself through that. So with PEMDAS comes parentheses. So it says plus 3 on the inside of the parentheses. A plus 3 is a shift left 3. And then multiplication left to right will take care of the negative next. So what's this negative out in front of the 2 do? That is a reflection. Now remember what we had before, the negative, that's the entire function. I always say that's the entire function of y. So if it's the entire function of y, it is a reflection over the x-axis. Go back and check the previous video. Over the x-axis. And then next, so this is technically what I'm saying happens first, second, and then the third thing that happens, I'm going to take care of that 2 out front. That is a vertical stretch. Vertical stretch by 2. And finally, the last thing, fourth thing that happens, that minus 1, that is a shift down. That is a shift down 1. All right, notice what I did all the way throughout. I did it using PEMDAS. Don't necessarily have to do it that way. But if you were graphing it, it would be important to follow PEMDAS. Example 6. So multiplication of 3 out front. That all that is just one thing that's happening to the function. That is a vertical stretch by a scale factor of 3. And finally, the last one, there's a 1/3 out front. That is a vertical shrink or stretch, I guess you could say, but shrinking of the stretch. Shrink by a scale factor of 1/3. So vertical shrink by 1/3 on that last one. Nothing else. Just keep in mind that it's multiplied to the entire function of y, so it's a vertical stretch or shrinking. If it was multiplied to the x, which we're not doing, that will be a horizontal stretch or shrink. Okay, so here's some standard functions. Again, I know I showed you these before, but we're going to need this for the parabola, the power function, f of x equals x squared. So I decided to show you them again. Some root, we're also going to have a root equation, square root of x. Okay, so here's the parabola one. It says, given the graph of f and g, find the equation for g. So all we have to do is take a look. First we talk about it's a parabola. So the first function we have f of x equals x squared. All right, that's this parabola with the vertex at 0, 0, 0. Now if we look at the graph, all we notice is that the parabola was moved down 1, 2, 3. So the graph was moved down 3. So that's a shifting down 3 to the function of f of x equals g, or f of x equals x squared. So now we have a new function, g of x, with a shift down 3. All that is g of x equals x squared. And I know that if I subtract 3, that represents a shift down 3. Simple as that. But you do have to know what the graph of f of x equals x squared looks like. Again, minus 3 to the entire function is a shift down 3. If it were inside the parenthesis with the x, that would be a horizontal shift left and right. Okay, so here is the square root function. So now you can see we're going to write the g of x function. And on this function, here's the square root of x, shifted to the right 1, 2, 3. So let's write the equation. G of x equals the square root of, right next to the x in parentheses, it's going to be x. Since it was shifted to the right 3, remember it was opposite, so x minus 3. And it's in parentheses right next to the x underneath the root. All right, so a shift of 3 to the right would be in parentheses with the x, but opposite, since it's to the right, it will be a minus 3. Okay, so finally, a couple more examples here. Finally, example 10. Now we're going to actually write the equation based off the given information. So it says, given f of x which it looks like is the cube root of x, write a function with the given transformations. Reflected over the y-axis, shrink vertically by a scale factor of 1/2, and vertical shift of 3. So let's just break this down. We can knock all this out kind of at once. We know it's going to be a new function. Let's call it g of x. And it's going to have the cube root of x. Now we got some things that are going to go alongside of it. Immediately I see the reflected over the y-axis, which tells me that I'm going to have to make something negative. And since it's the y-axis that we're being reflected over, we're going to make the x opposite. So we'll make the x negative. So far we have negative x. It's going to shrink vertically by a scale factor of 1/2. Shrinking vertical, that is out in front, so to the entire function. So 1/2 is going to be there by a scale factor of 1. And then a vertical shift of 3. So then add to the entire function, vertical shift 3. If it was horizontal, it would be underneath the root with the x in parentheses. But since it's a vertical shift of 3, it goes outside and add the 3 to the entire function. So we took care of 3 things. Reflected over the y-axis, that was the negative. Shrink vertically by a scale factor of 1/2, that was right there. Vertical out front of everything. And vertical shift of 3, there's the plus 3 for a final function right there. One last example, example 11. It says sketch the graph by starting with the standard function. It's a square function. This is why I showed you these before. A power function, so quadratic to the second power, which is just a parabola. So I know that a parabola is a standard function. Let's call it h of x, could be anything. It's just x squared with the vertex at 0, 0. The vertex at 0, 0 with a pattern of change of 1, 3, 5 that you learned in Algebra 2. So right one up 1, right one up 1, 2, 3, and right one up 1, 2, 3, 4, 5. Same thing the other direction. There you go, there's the parabola. All right, and now you make the parabola. There you go. That's just the standard function. Now what they want me to do is graph the function starting with the standard function, and now let's write down what this equation is actually doing for us. That plus 2, I'm going to work inside the parentheses first. That plus 2 is a shift left 2. This minus 1, that's a reflection. That's a reflection over, it's the entire function, so it's a reflection over the x-axis. If it was negative x, that would be a reflection over the y-axis. Remember, that's how I memorize it. And then this minus 4, I know it's out front here, but usually it's out back. Usually it's sitting over here. All right? But that is a shift down 4. Be careful you don't see that that is a vertical stretch. It's not multiplied to the function. It's actually subtracted from the function. So it's a shift down 4. All right? So if we sketch the graph, I'm just going to take these points. I'm going to take the vertex. I can move it left 2, and I also know that it's going to reflect over. So everything's going to flip over. So I'm going to take this parabola, move it left. Let me just group that together. Sorry about that. All the points get moved basically. So left 2, then reflects over the x-axis, which that point is, and then down 4. 1, 2, 3, 4. There's my new vertex. Let's move all the other points. So take this point here, I'm going to move it to the left 2, 1, 2, reflect it over the x-axis, and then down 4. 1, 2, let me do that again. Left 2, 1, 2, reflects over the x-axis, ends up there, and then down 4. 1, 2, 3, 4. My new point is there. I'll take care of this point now. Left 2, 1, 2, flex over the x-axis, and then down 4. 1, 2, 3, 4. A little bit of space here. And then one more, I'll do another point like this one. So left 2, 1, 2. So I took this point and moved left 2. Flex over the x-axis ends up all the way down here, and then down 4. 1, 2, 3, 4. Solid point there. I'll now do this point as well. Left 2, 1, 2. Flex over the x-axis, right there, down 4, 1, 2, 3, 4, right there, and here's where the parabola would be. Something like so. That is the equation of f of x equals -4 minus the quantity x plus 2 squared. If you have any further questions, make sure you ask me or Ms. Zara. But make sure you do go back and watch the notes if anything is confusing to you. Definitely go back and look. Otherwise, let us know.